everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic is Fourier integrals. We are going to discuss about Fourier integral formula, Fourier sine and cosine integral formula and problems. We are going to apply this Fourier integral formula while solving the problem, how to do. Everything in detail we will discuss through this video lecture. Now, the Fourier integral formula, it's nothing but 1 by pi integral 0 to infinity integral minus infinity to infinity cos p of t minus x f of t dt dp. This cos p of t minus x we are going to compare with the trigonometric, the basic formula, that is cos of a minus b is nothing but cos a cos b plus sin a sin b. So with the formula comparing, we got it, our a is nothing but pt, our b is nothing but px. So 1 by pi is written as it is. Integral 0 to infinity is written here, the same minus infinity to infinity, cos a, here cos b, because according to the formula, a is playing the role pt, b is playing the role px, so cos a cos b plus sin a, so sin of pt, sin b, so b is nothing but our px, so sin b. Remaining other terms, all f of t dt dp are written as it is. Now, here one term, this is one term. So we are splitted, we are expanded in such a way, 1 by pi as it is, 0 to infinity integral as it is, the cos px we have done it front, and integral minus infinity to infinity, cos pt f of t dt dp plus this containing, we wrote it in a separate integral, that is 1 by pi integral 0 to infinity sin px integral minus infinity to infinity sin of pt f of t dt dp. Now, this is nothing but Fourier integral substituting the basic formula, that is cos of a minus b equal to cos a cos b plus sin a sin b. After applying the Fourier integral formula is taking this formation. This we are naming as equation 1. From this formula, we are going to derive Fourier sine integral formula. For that, we are going to check whether the functions are even or odd functions. To check the given functions are odd or even, this is the basic rule, that is f of x equal to some function. This x is replaced by minus x. So we are replacing, after replacing the result, if it is minus into f of x, that is the given question, the given function into opposite sign, then it is it is an odd function. If it is f of minus x equal to f of x, that is we are getting back the same function, then it is an even function. We can check it here, cos of pt f of t. We are going to replace t by minus t, that is where t is there, we are going to substitute minus t. So cos of minus pt, f of minus t. We know the trigonometric formula cos of minus theta equal to cos theta. According to that, now cos of minus pt is nothing but cos pt. Then what about this? F of minus t is nothing but minus f of t. So that minus only here it is kept. And we are comparing, this is, we have taken the final result after replacing t by minus t, we got it this. So the same, the question is into the opposite sign, because here it is plus sign, here we got it opposite sign. It's nothing but odd function. So we are, this term is an odd function. The function is odd and the integral varies from minus infinity to infinity. These two conditions are satisfied, then the integral is vanished. That is a completely the Fourier integral, the first part is vanished. The reason is the integral ranges from minus infinity to infinity and the function is odd. Now we will check the second integral. The same here, we are taking this sine of pt f of t, replacing t by minus t. So sine of pt, we replaced it, sine of minus t. Here we are noticing, so the t is replaced by minus t. F of t, that is f of minus t. We know the trigonometric formula, sine of minus theta equal to minus sine theta. According to that, so now here sine of minus sine of pt, f of minus t is nothing but minus f of t. This minus into minus, we are getting plus. That's the reason here sine of pt f of t is written, and we are comparing with the given function. We have taken this. After replacing, we are the final function we are checking, both are same. Then we can declare the function is even. Now, so this function is even, the integral minus infinity to infinity, then this minus infinity to infinity, it is 2 into the integral minus infinity to infinity, it is changed as 2 of integral 0 to infinity. It is a mathematical rule for the even functions. Specifically, it should be in the limit minus infinity to infinity and the function should be even. We can write like this. So, the first integral completely it is vanished. The reason, this part is odd function and the range is minus infinity to infinity. Here, this function is an even function. So this is changed into 0 to infinity, 2 of the 2 we are going to become 1 by pi. We are going to change it as 2 by pi. So we derived from the equation 1, that is Fourier integral formula, from which we derived Fourier sine integral formula. That is this is the formula. So here minus infinity to infinity, the range, the limit was there in Fourier integral. After the substitutions, everything, it has become now 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp. So this Fourier sine integral formula, we named it as equation 2. Now this equation 1, we know it, that is Fourier integral formula, from which we will derive now Fourier cosine integral formula. So just we have taken Fourier integral formula here. Now for this, to derive Fourier cosine integral formula, we have taken this function, that is cos of pt we have taken. The same steps, that is replace t by minus t. That is the procedure to check whether the given function is odd or even. So we are decided to check now. So we substituted in the t place, we replaced it t by minus t. So cos of pt, it has become now cos of minus pt. The trigonometric formula, cos of minus theta equal to cos theta. According to that, it is written cos of pt. This function we have taken, we replaced it, final result we got it this one. Both are same. That means f of minus x equal to f of x. This condition is satisfied. Then we can declare this is an even function. Now, this part is even function. Suppose this f of t, this is a formula. Suppose the problem comes, the f of t, some functions if they are given. If that f of t is an even function, this is even, just now we checked it. This f of t is also even. Then both the functions are even. Even into even, it's nothing but even function. So we know it this completely if it is even function, and we will check this minus infinity to infinity. For the even function strictly, the integral will change into 2 of 0 to infinity. So the 2 we will bring it to front, 0 to infinity it will change. So the first integral exists taking this formation, that is 1 by pi has become 2 by pi. Integral minus infinity to infinity, it has changed to 0 to infinity. It has been changed to 0 to infinity. Because of the reason, even into even equal to even function. First integral, the work we completed. Now we will move to second integral. Now we are taking sine of pt. The same procedure, t is replaced by minus t. We are replacing. So sine of pt is nothing but sine of minus pt. So trigonometric formula, sine of minus theta equal to minus sine theta. Fine. So minus into sine of pt. This is the function we have taken. The result we are seeing, f of minus x equal to minus f of x. So it is an odd function. So this is odd function. This f of t is an even function. Odd into even function, it's nothing but odd function. That's what here, odd into even, it's nothing but odd function. Now, it is an odd function. For the odd function, the range, the limit, the integration from minus infinity to infinity, then the total integration is vanished. According to that, the second part, it has become 0. Only exists only the first part of the Fourier integral formula, from which now we derived it Fourier cosine integral formula. Now we will do a problem, that is, using Fourier integral formula, show that e power minus ax minus e power minus bx, which is equal to 2 of b square minus a square by pi into integral 0 to infinity lambda sine lambda x divided by lambda square plus a square into lambda square plus b square into d lambda, where a comma b is greater than 0, that means they are positive. This we have to prove it. Now the solution we will concentrate. We have taken here Fourier sine integral formula. We have Fourier integral, from which we just now we derived Fourier sine integral and as well as Fourier cosine integral. Here specifically, why we have taken Fourier sine integral formula, why not Fourier cosine integral formula? Is there any reason for this? The only reason we can tell now, the right hand side, this we have to show. If you are noticing here, the trigonometric term sine is dominating. That is the reason we selected here Fourier sine integral formula we selected. So the Fourier sine integral formula, it is written. This is to be proved, but the formula is here. What to prove in which there is not at all any p term it is there. But in the formula p, here p is there, here p is there. But what to prove in which there is no p term? Better, we can replace p by lambda. That step we can adopt. So that's what written here. We can notice it here. This 2 by pi as it is. This integral is written as it is. Whereas the changes we are bringing in the p place. That is, p is replaced by lambda. And this integral also written as it is. And this f of t. Here sine, the p is replaced by lambda. So sine lambda t. Here dt. Here d lambda. 2 by pi. Here integral 0 to infinity. Sine lambda x as it is. Everything we are writing as it is. Here dt, d lambda. Only the difference, this f of t is not written as it is. The question, that is our problem, the left side it is given e power minus ax minus e power minus bx, which is given. It's this nothing but f of x. This f of x, but in the formula we have f of t. So better x we can replace by t. So e power minus ax, x is replaced by t, minus e power minus bt. This is one term, this is another term. So better we can expand this, the integral, into 2 times. So here containing e power minus at one time, e power minus bt with another time it is written. Now, this integration, how to do it? We have in the lower classes we studied integration by parts, UV method, the different methods we studied to solve the integrations. Now, the mathematical formula which is available, the combination of exponential and trigonometry, we can take easily, we can solve and we can come out. Now, the formula is e power ax sine bx dx, which is equal to e power ax by a square plus b square into a into sine bx minus b into cos bx. The formula which is ready now. This formula we will compare with our problem. Now, comparing, we will do it. E power ax, it is in the formula. But what about our problem? It is e power minus at. The meaning is here a is there, whereas here minus a is there. So in the formula a, but our problem minus a. In the formula b, but our problem lambda it is there. First that we should do the comparison between formula and our problem what is there. We did the comparison for the first integral. That we will do it. Now this part first we will concentrate. This integral which is written as it is sine lambda x, it is written as it is. We are going to substitute here e power ax, but this we are concentrating. Our a is minus a. So e power minus at, a square, it is written as it is. So a is replaced by minus a. But minus a the whole square, it's nothing but a square. So a square. B is playing the role lambda. So lambda square. A, according to our problem, minus a. Sine. B, according to our problem, lambda. Here x it is there. That is, here in the formula which is integration with respect to x. But our problem it is integration with respect to t. That also very, very important point to be noted while solving the problem. It is integration with respect to t. That is the reason here t is playing a role. Minus b is nothing but lambda cos bx. B is nothing but lambda. X is nothing but t. Because completely our problem with respect to t we are doing the integration. So now we completed the first one. The second integral we will concentrate now. So same way we are going to do the comparison with the formula. So when we are doing the comparison, here in the formula a is there, whereas in the problem minus b is there. Here b is there in the formula, whereas in the problem lambda is there. First that we have to pick, then we can substitute without committing any mistake. Now this minus is written as it is integral 0 to infinity. That is, we are after doing the integration, the symbol it won't be there. So it has come out here. So e power ax, our a is minus b. With respect to t is our problem. This is a square. Our a is minus b. So minus b the whole square. It's nothing but b square plus lambda square. Here minus a is nothing but minus b. Sine bx, that is sine lambda t, minus b is lambda. So cos bx, it's nothing but cos lambda t, 0 to infinity d lambda. So according to this formula, we expanded. So it is written once again. Now we will substitute the limit, that is from 0 to infinity. We know that upper limit will substitute. Our upper one is infinity minus, this is related to formula. Then lower part, lower is 0. That we will substitute. E power minus infinity, the value is 0. E power 0, the value is 1. This two we have to remember. Now, so we can see it here. Here also 2 by pi is there. Yeah. 0 to infinity. This sine lambda x. The upper one is infinity. So we substituted here. It has become e power minus infinity. So e power minus infinity. So this part is becoming 0. 0 into anything 0. The totally upper part it has become vanished. This is formula minus. Lower part, that is which place we have to substitute in the place of t. So e power 0 we are getting. E power 0 is 1 divided by lambda square plus a square. Here we are substituting in the t place because completely we are doing integration with respect to t. So t place we are substituting sine 0, it has become 0 minus lambda. Cos 0, the value is 1. So lambda into 1 lambda. That is the reason here it is written minus of minus lambda by lambda square plus a square. So the first integration we substituted the limit, that is from 0 to infinity. Upper we substituted minus, lower one we substituted. Following the values, e power minus infinity equal to 0, e power 0 equal to 1. Now the second one we will concentrate, that is the same way. This minus is written as it is. The upper one is infinity. So here we are substituting e power minus infinity. It's nothing but 0. So the upper one completely it has become 0 minus, that is a formula minus. The lower one is 0. We will substitute in the place of t e power 0. E power 0 is nothing but 1 by lambda square plus b square. Sine 0 0 minus lambda. Cos 0 is 1. So that's what here it is written. Minus lambda by lambda square plus b square. The next one, this 2 by pi, it is written as it is. 0 to infinity is as it is. This sine lambda x as it is. Minus into minus, it has become plus. So lambda by lambda square plus a square. This minus here. Here minus into minus plus. lambda by lambda square plus b square. Next, this lambda, we brought it outside. So if you are bringing outside this part, it is becoming 1 by lambda square plus a square minus 1 by lambda square plus b square. We are doing the cross multiplication. Then lambda square plus b square minus of lambda square plus a square. So lambda square plus b square minus lambda square minus a square. Lambda square getting cancelled. The balance is b square minus a square, which is kept here. So we completed the first problem. What we have to prove it, we proved the right hand side. The next problem we will concentrate. Using Fourier integral, show that e power minus ax equal to 2a by pi integral 0 to infinity cos lambda x by lambda square plus a square into d lambda. Here the function is e power minus ax. Here what we have to prove, it has cos, the trigonometric term. That is the reason here we selected Fourier cosine integral formula. In this problem, since the right hand side has the cosine term. So the Fourier cosine integral formula, we know it. 2 by pi integral 0 to infinity cos px integral 0 to infinity f of t cos pt dt dp. Our f of x is nothing but, in the problem which is given, e power minus ax. That f of t is replaced by, in terms of x it is there, but our formula it is in terms of t. So e power minus at, which is replaced by f of t. Remaining all the terms are written as it is. And what we have to prove, in which there is no p term. Everything it is in terms of lambda. So that is the reason in the formula p, 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 the three places, the p, that we are going to replace by lambda. So we replaced it. Then 2 by pi, here cos lambda x, here 0 to infinity, e power minus at, here cos lambda t dt, here the dp has changed into d lambda. So 2 by pi, here the trigonometric, here exponential is there and the trigonometric term cos is there. So integral e power ax cos bx dx, that formula we have to use it. Exponential combination with the trigonometry, the formula is e power ax by a square plus b square, a cos bx plus b sin bx. So we have to do the comparison with our problem. So when we are doing comparison, we are getting, this is our formula, this is our problem. So our formula A, but our problem A is minus A. Our formula B, problem lambda. That in this we are going to substitute. So 2 by pi, we substituted in this place. That is e power minus a, not x. Our problem is with respect to t. We are doing the integration with respect to t. That is the reason e power ax. Our a is minus a divided by a square plus b square according to formula, but our problem b is lambda. So lambda square, here a, our problem a is minus a, cos bx, it should come, but our b is lambda. Our problem integration is with respect to t plus b, our b is lambda, sine bx according to formula, but according to our problem lambda t, 0 to infinity. E power minus infinity, the value we know it 0. E power 0 value we know it 1. So that keeping in the mind, we will do the the limits we will substitute. Now 2 by pi integral cos lambda x, the upper one infinity, e power minus infinity, totally it is vanished. That is the reason here the upper one it has become, the value is 0. This is formula minus, because upper limit minus lower limit, the lower one is 0. So the e power 0, the value is 1 by lambda square plus a square minus a, cos 0 is 1, sine 0 is 0. So minus a, this term we got it. Now 2 by pi integral 0 to infinity as it is, cos lambda x as it is, minus into minus plus, so plus a by lambda square plus a square d lambda. Up to this we got it. The next step, what we have to prove, in that in front of the integral 2a term is there. That is the reason a we are pushing to front. 2 by pi, it has become now 2a by pi integral 0 to infinity cos lambda x by lambda square plus a square d lambda. We will concentrate one more problem, that is express f of x equal to, if x lies between 0 to pi, the value is 1. X is greater than pi, that means pi to infinity, the function we have to take it as 0. As a Fourier sine integral you can express, that's what it is given. So we are writing, this is the given function. The Fourier sine integral we know it, 2 by pi integral 0 to infinity sine lambda x integral 0 to infinity f of t sine lambda t dt d lambda, that we named it as 2 equation. Substituting 1 in 2, that is what is given the question. Here on the question 0 to infinity, 0 to infinity, it is there in the formula. But here the function strictly it is given, x lies between only 0 to pi, you can take it as 1. Remaining all it has become 0, but in the formula there is no 0 to pi, the limit range only it is not there. Then pi should be inserted. So the first up to here as it is we have written, this 0 to infinity, that we are splitting, that is the reason pi we are inserting. Strictly it has been told that 0 to pi it is there, f of t is taking the value, the function is 1. So we inserted correctly or not, easily we can check. Pi is 1 is up, what we inserted 1 is down. Just if you're crossing the remaining part, we should get the previous step. Now the previous step, the formula what it has, 0 to infinity. This is the way we won't get any careless mistake. So f of t sine lambda t dt plus pi to infinity. This how to read. The reading part is t lies between. Why I am using the t lies between? Because we are doing the integration with respect to t. So t lies between 0 to pi. It is given in our problem. The function value is 1. Other everything it has given in our problem 0. That means here how we will read. T lies between pi to infinity. That integrand is vanished. That is according to our problem. So f of x 2 by pi integral. This all it is written as it is. Only this f of t it is replaced by 1 according to satisfying the condition of our given question or given problem. Sine lambda t dt. Second integral it is vanished. This is also the reason, the condition which is given in our question. This as it is, this is also as it is, sine lambda x 1 into sine lambda t dt. Sine, the trigonometric the term, we know the integration. Sine, the integration is minus cos. So we did the integration minus cos lambda t by lambda. That means the t coefficient is lambda. Because of integration, divided by the coefficient will play a role. That is also we have to keep in our mind the difference between differentiation and integration. Because of the integration, sine lambda t, the integration cos minus cos lambda t divided by lambda. Integration, whereas a differentiation, this lambda will play a role. In multiplication, the coefficients will play a role. That is also while doing the problem, we have to check ourselves and we have to proceed. Yes, next we will, the upper one is pi, the lower one is 0, we will substitute. 2 by pi, remaining all as it is we have written. Minus cos, in which place we have to substitute? In the place of t, the entire thing with respect to t, we are doing the integration. So the t place, the pi is substituted, that is the upper one is pi. This is the formula minus, the down one is 0. So minus cos 0, the value is 1. So minus 1 by lambda. So the next step, as it is 2 by pi, integral 0 to infinity, sine lambda x, minus into minus plus 1. This is taking the position lambda pi by lambda, minus into minus plus 1 by lambda. In a short form, it is written 1 minus cos lambda pi by lambda d lambda. So f of x equal to, this is only our question. So the f of x, just know what we, as a Fourier sine integral, substituting what we got it has been kept. This 2 by pi, just we pushed to the right side, 1 into 2 by pi, the next side pi by 2, 1 into pi by 2, pi by 2, 0 into pi by 2, 0. Yeah, we have come to a conclusion that Fourier integral formula. So we have this we discussed in detail, and we used the basic trigonometric formula cos of A minus B equal to cos A cos B plus sin A sin B. Using that, we derived Fourier sine integral formula, checking even and odd functions, and Fourier cosine integral formula also, checking even and odd functions, checking we did. And we did 3 problems also using Fourier sine as well as Fourier cosine integral formula. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.